Even though I don't have the third question highlighted as one that we really need to focus on because it has the word interface in it, it's actually a great question. And the fact that these are interfaces really hardly even impacts the question. They could have just implemented classes here. It wouldn't really change how you're going to write your answers at all. The bottom line is there's two user-defined things here, and they both have stuff they can do. We got to figure out what they can do, what we can do them to, and how to use it as needed. So here's a fuel tank. Okay, I don't know what a fuel tank is, but apparently you can get the fuel level of it as an int, and it's going to range from 0 to 100. So we're going to see a fuel tank in this problem, and we're going to get the fuel level of it. It's going to come back to us as an int. The fuel tanks are stored in an indexed storage system. We'll see that it's an array list. And there's a robot that moves around to the various fuel tanks that have various fuel levels. Okay, so here's what a fuel robot can do. A fuel robot can do four things. We can ask for its current index. Their example would be 2. We can ask if it's facing right. In their example, it would be true. We could change the direction of it, make it point left, and we could move it forward. Little note on this problem here. This has a precondition that says num locus has to be greater than 0. If we're writing code that's going to determine the value of num locus to be used, which we will later in this problem, we cannot violate that precondition. And it's subtle. We could end up putting 0 in pretty easily if we weren't careful when we do part B. So that's just something we'll have to pay a little bit of attention to later. All right, so as we saw, the fuel tanks are in an array list. That was that indexed storage system we saw. Every tank has a different fuel level. We can ask for it. So give me a tank, I can get its fuel level. And there's a fuel robot moving along this row of fuel tanks. Okay, I can ask what direction it's pointing. I can change its direction. I can ask where it is, and I can move it. Okay. In part A, I need to figure out which tank to fill. In part B, I have to move to a new location. All right, so part A, a little bit more detail. A couple things to note. The tank that's got to be filled has to meet a few criteria. So it's got to be the tank with the lowest fuel level. So we're going to need a minimum method. We'll have to walk across every tank, determine its fuel level, and figure out which one has the minimum. If there's a tie, we don't care. It could be either of them. However, once we get the minimum, it's not guaranteed we're going to return the minimum. It has to be less than or equal to a given threshold that's going to come in as a parameter. So that comes in as a parameter. Once we have our minimum established, if it's less than the threshold, we'll return it. If not, we're going to return the robot's current index. Remember, there's a method that can tell us that. So it'll be like an if-else scenario once we have that minimum determined. Okay, so like I said, basic minimum problem. The minimum is going to be in this array list. The array list holds fuel tanks. Fuel tanks have a fuel level that we can ask for, right? So the method is get fuel level. So you give me a fuel tank, I can get its fuel level. And if I have its fuel level, I can then go on and figure out like which one's the smallest. So this is an index-based return. So I think it'd be best to write an index-based method. Okay, so let's call it min index. Okay, we'll start it at 0. We'll write a loop to handle all of the other potential indexes of the array list. The name of the array list is tanks, so make sure you're using the correct name of your variable. Okay. So remember, what the array list has is a fuel tank. Okay. So if you go into tanks and you get something, it's a fuel tank. You don't really need to write that line of code. You could combine it into this next line I'm going to write. So if I have that tank and I go ahead and I ask for its fuel level, how does that compare? I'm going to go back to the tanks array list. I'm going to get the one that I think has the minimum in it, and I have to get its fuel level. Okay, so if it was smaller, then I need to swap out these indexes. All right. Okay, so right here, I've got the tank that came to me from the loop. I got its fuel level. Over here, I got the tank that I think has the least amount of fuel in it, but I'm not sure. If I was wrong, I'm going to change my index. All right. Normally at this point, I would write return min index. There's one extra catch here, right? We need to go back to the tanks array. We got to get the one that we just found, the one that was at min index. We need to get its fuel level, and we need to verify that it's actually less than or equal to the threshold. They did say equals in their directions. Okay. If it is, I will return the min index. If it is not, okay, then I'm going to return the robot's current position. Now, we haven't really talked about the robot yet. Remember, there's a robot that belongs to this class named filler, and we know that all robots have a method called get current index. Okay, we could have maybe even written code that like started here, for example. So like that could have been like our initial position, and then we could have gone and looked at other ones. But this is fine. So again, we could, I'm sure we could condense this code a little bit, but this should be just fine. All right. So that's our fallback plan, right? If there is no tank below the threshold, then we're going to fall back on the current index of where the robot is. And they did mention in the directions that if there's a tie, you can return either. So the first example said it could have been tank 0 or 6. We see that we got 0. You'd get 6 if you made this like a less than or equal to here. That'd be fine. And then later we got tank 2. Okay. All right, looks good. On to part B. Now we've got to move this robot. And remember, the robot's pointing to a direction. So if the robot was like at space 2, like in their example, and you wanted to move it to space 0, you'd first have to turn the robot around, because this robot can only move forward. So remember that the move forward method only takes a positive number. So you'd first have to turn the robot around and then move it forward. And there is that weird case too. I'm not sure if they penalize it or not, but if you actually told this thing to move 0 locations, you'd violate that precondition. So if you're at index 2 and they tell you to move to index 2, well, that's not good. That technically, if you put in 0, I think you would lose points. So that's pretty tricky though. And so I think the first thing I would do is I would just figure out, like, do I need to change the direction that I'm moving? Okay, and then second, once I had that figured out, then I would go ahead and move it. So how would I know if I needed to change the direction? Well, I guess I see 2 things. If it's pointing right and the move to location is left of where it currently is, I need to change its direction. Or if it was pointing left and the move to direction is to the right of where it currently is, I need to change its direction. And then once I knew I had it pointed in the right direction, I'd go ahead and move it. And so yeah, let's see. So maybe I'll go ahead and just figure out where it currently is. So I'll just say like int current index equals, I'll call up filler again, just like I did a minute ago, and I'll run that get current index method that we just did. Okay. I guess we could even make an if right here too, like if loc index equals current index, return, and then that would just kind of break us out of this method. Or we can avoid it later too, but you don't really want to do anything if it's going to that current one. So maybe something like this, like if current index is not equal to loc index. So I only want to attempt to move this fuel robot if I need to. right? Like why would I move it if I don't even need to? If they're just telling, if it's at position 5 and they're telling me to move it to position 5, then like what's the point? So anyway, I figured out here that I do need to move it. The thing I'm going to do next is figure out if I need to change its direction. So if filler dot is facing right, I believe that's the method. Let me go double check. Yeah, is facing right. So if it's facing right, okay, and loc index is less than current index, okay, that's one thing that I'm worried about, right? Or I guess there's another one too. The other one would be is if it's not facing right, so not filler dot is facing right, that would mean it's facing left, and loc index is greater than current index. So it needs to move right, but it's not facing right, okay? Or it needs to move left, but it's not facing left. In either of those scenarios, I need to take filler and change its direction. Okay, all right. Now the robot is pointed in the correct direction. We know that it needs to move. So at this point, all I need to do is figure out the difference between loc index and current index and move that far. The last trick is this could be a positive or negative number, but when we put it into the move method, remember the precondition says it has to be positive. So when I call move forward, I've got to make sure it's receiving a positive number. So I'll use math.abs to verify that. So math.abs, and I'll take current index minus loc index, or vice versa. It doesn't actually matter because I'm doing math.abs on it. Looking at my code too, I'm thinking that maybe I should have like done a subtraction between current index and loc index right at the start, and then I could have just said, you know, like not equal to 0. Depending on how I wrote it, I could have said less than 0, greater than 0, and then I could have just used that difference here. But this is fine. I don't really consider this to be excessive, and I don't see any helper methods that I could have called, right? So 531440 looks perfect. Okay. So we got all of the correct locations at the end after the move was done. That's like where the robot ended up after the call. So all of those turned out great. And yeah, no loop here, right? This was just going through and calling methods. Again, I know this problem had interfaces in it, but this is what the College Board wants to see in terms of methods and control structures. So here's an object, here's what it can do, here's like what its methods look like, here's some preconditions, here's some parameters, here's various return types. Can you work through these different methods and get it to do what is needed? The interface here really doesn't impact the problem at all. I mean, they could have just said public class fuel tank, and then they would have had to put a note in, like, you know, there's other stuff here you don't see, like the constructors and instance fields, and they do that all the time. So I know this problem says interface, but really this is a great practice problem. We might see something just like this on our exam. This is that idea of being able to write object-oriented programming code. All right.